Hello and welcome to It's Probably Coding. Today we're talking about lists, tuples, and sets, things that I use all the time when doing data analytics or data science. Lists. Let's start with lists. I'm just going to straight up copy and paste the code that I have here, and we're going to explain all these things before we print it. List. A list is essentially a variable, but it's a container. It can hold multiple values. How many? Lots. It can hold lots. But the great thing about a list is you can change it however you want. You can add things to the list. You can remove things from the list. If you have a value in the list, you can straight up find that value and change it to whatever you want it to be. So here we have monthly sales. And to create a list, we have monthly sales, which is the name of the variable, equals, and then in square brackets, we put our values here. So we have a list, which is everything between these square brackets. And I just printed the original list, which you'll see exactly this if I were to print or if I were to run. Original list is that. Yeah, okay, not that exciting. Append. Append adds a single item to the end of the list. So 140 will be at the end of the list. Now I'm going to prove that to you by showing you. 140 is now at the end of our list, right there. At the end of our list, right there. So we're going to carry on, and we're going to say dot insert inserts a number at a specific spot. So we have, let's create a list. So XX, XY, XZ, XA, ZA, ZB. Okay, so let's say we have a list that is this. And I wanted to show the positions of each of these. XX is at position 0, XY is at position 1, XZ is at position 2, XA is at position 3, and XB is at position 4. I should have explained this before, but these are the positions in the list. Now, you can also go backwards. I shouldn't go over this today, but -1 is technically the last position here, and -2, and then so on and so forth. So if you have like a huge list, you can find the last item or the second last item of the list by using -1, -2, etc., etc., etc. So here we go. We're adding the number 200. We're adding 200 at position 0, which means put 200 at the beginning of the list. So we'll see here, after insert at index 0, you'll see 200 before the 120. Okay, so add multiple items at once, use dot extend. How you use that is you straight up put your new list that you want to extend onto the old list inside the brackets here. Okay, changing a specific item. You have to put the name of your list, and then in these square brackets, you put the where the like I said here. So you have a list here, X, Y, Z. This is position 0, this is position 1, this is position 2. You put the position inside these square brackets of the value. So position 2 would be the Z. And you want to change it you want to change to 160. So this Z is now going to be 160 if we were to use that on this list. So here, you'll see that we have 200, 120, 95, 200, 120, 160. So position 2, which was 95, is now 160. So you can change a specific item. So if there's a typo or something, you can use that to change. You can remove the first match. So if you do use dot remove, the first 80 in there, it'll pop it out. You can use literally dot pop. It'll get rid of the last thing on the list. Dot sort, which is great for alphabetical order, which I don't have an example here, but dot sort puts everything in order from lowest number to highest. And then if you dot reverse it, it'll flip the whole list. So now it'll be the highest number to the lowest. Great for putting things in alphabetical order or reverse alphabetical order. If you want to put something in reverse alphabetical order, use the dot sort. Now it's alphabetical. And then right after, use dot reverse. Now it's in reverse alphabetical order. You can find the position of a value. So say you want to find the position of 150. Like, where is the number 150 in my list? And it'll show, it says number 9, index of 150. Which means it's the third thing in the list. And the last thing is dot count, which I use all the time in data science. In my EDAs, when I'm getting to know my data, right at the beginning when I have a huge data set and I'm reading through the database and I'm trying to get to know the code and I'm trying to get to know the numbers. Dot count. Dot count is in every EDA, which means exploratory data analysis. It's like you getting to know the data. And you show like charts and stuff so that the person reading through it can also get to know the data. We want to count to see how many times 95 is in this list. Now I'm taking a look. I don't see 95 in the list because we popped it out, or we actually changed it. If you look at number 3, we changed the 95 to 160. So if you look down at number 10, the count of 95 is 0. It's straight up not in our list. So those are a bunch of things that you can do with lists. They can be changed. You can add things. You can remove things, etc., etc. Now we have tuples. Tuples are like a list. It's a container, but you can't change it. You can't add things to it. You can't remove things to it. You can't change a value in it. It's stuck. If you want to add a value or add something to a tuple, you have to create a new tuple and say the new tuple is the old tuple plus this. So you're essentially creating a new variable or a new tuple to add things to that existing tuple because you can't change the original one. They're locked. So the example I used is store IDs. So none of your code down the road is ever going to change the store IDs, because I'm telling you, sometimes you can do something and it changes the core list and causes some problems. So that's what tuples are for. So here we have our original store IDs, 101 to 105. You can find the position by using .index. I'm going to go through this fast because it's pretty much the same as list. You can use .count to find how many 101s are in there. This will output one time. You can slice. I don't think I used the word slice, but that's an important word. You can oh, there it is. You can slice through the tuple to show the first 3 things. Here in the square brackets here, we have show position 0 up to position 3. Don't show position 3, but up to position 3. So it's going to show 0, 1, and 2 positions. When it gets to position 3, it's like, okay, I'm gonna stop. So here we'll look at let me run this. It'll show, as you see, our original tuple is 101, 102, 103, 104, 105. And our sliced tuple, which is 0:3, it'll show 0, which is 101. It'll show the first position, which is 102, and the second position, which is 103. When it gets to the third position, so 0:3, it'll stop. So it doesn't show 104. Concatenation. You can add 2 tuples together. What that'll do is, here I created a new tuple called new stores. Remember, we can't add to the old tuple. We have to create a new one. New stores is 106 and 107 because our old one finished at 105. So 106, 107. We got 2 new stores. And I'm adding store IDs, which is 101 to 105, with new stores, which is 106, 107. So our new full store thing called all stores, that tuple, is going to have new stores and our old stores, which is store IDs here. So we're adding those 2 together, so we have all this. We have 101, 102, all the way up to 107. So if you want to add tuples together, you can. Multiplying tuples just repeats what's inside the tuple. Of course, we have to create a new tuple because we can't change the old ones. I created a new tuple called repeated IDs, and I did store IDs, which is 101 to 105, and I multiplied it by 2. And you'll see what it did here, right? You'll see what it did. It did 101 to 105 twice. You can do multiply by 3 to triple it. Is active. So now we have our operator. This is our in operator. You can see if there's a value inside your tuple by using the in operator. Is 104 in store IDs, and it'll return a Boolean. So it'll return true or false. If it's in it, it'll say true. You can check the length of a tuple by using the length method here, len, and then inside your brackets here, you just put the name of the tuple here. And then you can find the max value, which is the biggest value, and you can find the minimum value, which is the lowest or smallest value. in your tuple. I use this all the time, very useful. And the last thing is you can unpack. So you can get your tuple, which has 5 values in it, and you can store those 5 values as their own variables. So for example, I know I have 5 values here, so I'm creating 5 variables, all at the same time. So variable 1, S1, comma, S2, comma, S3, S4, and S5. And that'll store, let me scroll up here, 101 to 105. So S1 will be 101, S2 will be 102, S3 will be 103, S4 will be 104, etc., etc. So you can unpack the values of store IDs and store each value into its own thing. So for example, you'll see the unpacked first store is 101, the second store 102, and I just stopped it at that. So that's tuples. You can't mess with tuples. You can't change them. You can't change their core values, but you can use those values in the tuple to create new tuples. Okay, and then we have sets, which sets I definitely see in data, but they're a very uncommon, I think, structure in regular Python code. Sets drop duplicates automatically. So if I have a set, again, which is a container like a list, but if I have a set that has 1, 1, 1, 2, 3, and I printed it, it would just show 1, 2, 3. So if there's a duplicate, it'll just drop it. So for example, items sold here, I have hat, shirt, and shoes. We're going to try to go over this quickly. You'll notice that it just types or outputs shoes, hat, and shirt. You can .update. You can add multiple items to a set all at once by using the .update method. And inside the brackets, you straight up put a new set and it'll add it to the old set. You can remove an item by using .remove. And you can also remove an item using .discard. What's the difference? If you use .remove and the item doesn't exist in the set, it'll proper give you an error. It'll give you a key error. I typed that wrong. It'll give you a key error, which is good sometimes. You want to get those key errors to know that it doesn't exist. But if you want to remove an item, not get a key error, just like carry on with your life, use .discard. Next, we have you can pop out, same as a list. You can use the in operator, same as a list and a tuple, to see if something is inside that container. And you can make a second set of items here to now start doing some math examples. Math examples like .union. .union will combine both sets. So I have this set here, which is yesterday's items, and I have my original set, which is, what is it called? Items sold. So now I'm using .union, and what that'll do is, let's take a look at number 7. It'll add both of those sets together into one big set. And of course, when you print it, it'll only show the unique items, right? So it's not going to drop, it is going to drop all the duplicates. It's not going to show the duplicates. Intersection will find items that are sold on both days. For example, if you have 2 sets, that is 1, 1, 1, 2, 3, and then you have a second set that is 2, 3, 4, 5, 6, 7. Intersection is going to show you the things that are on both of those sets. So it'll show 2, 3, because 2 and 3 exist in both of the sets. Everything else that is unique to those sets is dropped. So that's what intersection does. Then we have difference. Difference will find the items that are sold today, which means the items that are unique to one set. So let's take a look at items sold, which is our original list. Our original list, hat, shirt, shoes. So it's really only hat, shoes, and shirt. And then we're finding the difference from yesterday's items. Yesterday's items is, where's yesterday's items? Shoes, gloves, belt, and bag. So it's going to show the difference between those two, and it'll show only socks, hat, and coat. So stuff that was the example I have here, sold today only. So sold in that set only. And the last one is symmetric difference. That's the items that were sold one of the days, not both. So if we have, let me go here. Let me say we have a list of 1, 1, 1, 2, 3, and then another list that is 2, 3, 4, 4, 5, and 6. Symmetric difference will get rid of these bad boys. So it'll do the opposite. It'll do the opposite. It'll only show you what is, it'll show you the 1, it'll show you the 4, 5, 6. So we have difference here and symmetric difference, two very different things. Symmetric difference will show you, in this case, the items sold on one of the days, not both of the days. So not the ones that were sold on both of the days, which is 2 and 3, because that's on both days. But this is sold on one of the days, and this was sold on one of the days, and this was sold on one of the days. So symmetric difference will get rid of the items that exist in both sets. I think that's pretty much it. So lists, tuples, and sets are containers, and they're used for different reasons. Depending on the reason, you're going to want to use the right thing. I hope that really helped. If that did help you study for your test or get something done, please drop a like and subscribe. And if you did some kind of a project using lists, sets, or tuples, paste it into the comments so we can see it. See you in the next video.